What if your thoughts weren't private anymore? What if a machine could read your mind and write your secrets? Meta's latest breakthrough isn't science fiction. Using advanced AI, they've decoded brain signals into text with shocking accuracy. No implants, no surgery, just pure innovation. Stick around if you want to find out how this mind reader works and how the future of humanity could be at stake. But first, we'll take you back to where it all started. In a quiet lab in San Sebastian, 35 volunteers typed simple sentences while an AI watched their thoughts. Meta's collaboration with neuroscientists developed an AI model, often referred to as decoding, that can decode brain signals to translate the sentences typed by volunteers. They then used the AI model to map out how the brain can actually produce language. To put it in short, this AI model can turn your thoughts into sentences on a computer before you even realize yourself and what you want to say. Crazy, right? Here's how it works. Every keystroke sends magnetic ripples through the brain. Brain to QWERTY captures these signals 1,000 times per second, while AI maps neural patterns to letters. The result? The quick brown fox becomes code, then text, with 80% accuracy. For Sarah, a trial participant has early-stage ALS, which is a deathly neurological disease, struggling with muscle weakness and paralysis. If you were to put yourselves in Sarah's shoes, you'd be terrified of all the things you were able to do freely escape from your hands. But if you had access to this mind-reading machine, this meant spelling help with pure thought. No voice, no movement, just hope made visible. This isn't telepathy, it's Meta's $2 million brain decoder. For people like Sarah, this is a huge breakthrough, especially from a medical perspective. Now, let's compare how machines with the EEG-based method recorded brain signals back then to the MEG. In a nutshell, EEG records electrical activity in the brain, while the MEG records magnetic fields in the brain. In terms of accuracy, MEG takes the lead here. Meta's AI can predict up to 80% of written characters using MEG data, while EEG isn't as precise. MEG requires a magnetically shielded room and complex machinery, making it bulky and expensive. EEG, on the other hand, is portable and widely accessible. Yes, it's cheaper, but it was a lot more disorganized and messy. It's like reading a book through frosted glass, but the MEG? A total microscope for the mind. If we take a look at the signal quality of both machines, MEG wins again. Since recording magnetic fields are less distorted by the skull and cerebrospinal fluid, MEG naturally has better spatial resolution. Its signals aren't distorted by the skull and scalp, giving AI cleaner data to work with. EEG signals, however, are more affected by interference. The brain to QWERTY is great and all, but I'd be lying to you if I told you that this AI model is absolute perfection. Meet the star of our show, a 1,000-pound machine that hates movement. If you sneeze, the data is ruined. Blink too hard? We gotta start over. Even meditation masters need bathroom breaks. This tech not only demands absolute stillness, but it also requires a room-sized Faraday cage and freezing temps. Imagine having to prepare a whole room just to communicate your thoughts to someone. And let's say that it did work perfectly. Your shopping list becomes data gold. If this AI tech is having complete access to your thoughts, there is quite the possibility that someone could be hacking into the system and into your brain. A dystopia where Meta knows you wrote "I hate Zuck" before you backspace. And what happens when this tech misreads your thoughts? Total mayhem. One wrong letter could twist "I love you" into "I loathe you." The stakes? Higher than you think. We often think of our thoughts as words in our minds, as if we have an internal narrator constantly speaking to us. But what if I told you that there is more to the brain than we think? What if I told you that your brain doesn't actually think in words, but composes symphonies of electric and chemical signals? Imagine trying to translate a full orchestra into a single melody. This is exactly what words do to our thoughts. The brain processes information in a complex, multi-layered way, with neurons firing in synchronized patterns, forming what neuroscientists call neural representations. These patterns encode emotions, sensory experience, and abstract ideas long before they become words. Our thoughts don't start as fully formed sentences, instead they begin as raw, chaotic bursts of neural activity. Think of it like sculpting. Our brains first generate a rough idea, then refine it through layers of processing. When you have a thought, it doesn't start with words, it begins as something raw. Just a spark of an idea, an emotion, or an abstract concept. At this stage, it's completely formless, like a cloud of energy moving through your mind. Next, your brain starts shaping this raw thought into something more recognizable. It takes that cloud of energy and begins molding it into familiar symbols, images, or even sounds. Almost like a mental sketch. Then, your prefrontal cortex, the part of your brain responsible for logic and organization, steps in. It takes these mental sketches and translates them into structured language. This is where thoughts start turning into actual words, forming sentences in your mind. Finally, your brain activates the motor system, transforming those structured sentences into action. Whether you're speaking, typing, or even gesturing, this is the moment where your thoughts become reality. But here's the fascinating part. Most of this happens in milliseconds. You don't even realize it's happening. Your brain is constantly translating thoughts into language, filtering out the chaos and delivering only what makes sense. And that's why technology like Meta's AI is so groundbreaking. It's attempting to tap into this process at its earlier stages, decoding thoughts before they even became words. Yes, this could be a big breakthrough with AI having access to our very thoughts and minds. The possibilities are literally endless, but with great power comes risk. Could this become surveillance or salvation? We can't really tell. One thing's for sure, the age of silent communication has begun. Who knows, you might actually be able to command your own humanoid robot like this one here, without saying a single word, just your own thoughts. However, if you'd like to know more about this humanoid robot, click here to get into a deep dive on this robot backed by OpenAI and find out more on its capabilities. The big question we now have to ask ourselves is, will we control this tech, or will it control us? Let us know what you think. Is this the first step to something revolutionary, or is it the first step to our downfall for humanity? Thanks for watching.